My turn, what? I did too. Everybody did. But I don't. Alright, the rest of
Got it, actually. Sorry.
Yeah, if you haven't turned on page 143.
I don't want you to rattle. Where am I at? Am I right here now? Yeah. Hi, brother.
You're the go.
No, you are. You have to go today. Connor said that. If you're the PSAT, you have to go today. I'm ready to.
Where am I at? Ward!
Doug up.
I sit here, my own.
Ward, where is it? I wasn't here.
What? What? Nick, you're still looking to sort of risk thing. Wait, what did I have?
You made one more day.
I know. Yeah.
Well, I didn't actually buy it today. I think it's actually. You know it's Patrick Honey.
Oh. I went to see more that night to the Main Street.
Yeah.
I like that Main Street.
Well, I had some action.
And then I heard when you took off, you shot rocks at Jack.
Rocket?
We got rocks at home. Yeah. I know it's
Yeah. You walk around the corner. Put back up.
That's why next Sunday we're going out back to the cemetery.
What? What?
Hey Jack, Connor, where were you guys at this morning?
Not following him. I just looked there from my hand. Nick, no.
What? They're supposed to be in English doing their speech.
Now Jack
Now I gotta
Thursday
get mine
by
on
himself.
Thursday. I'm gonna be gone for the TSAT tomorrow.
You're gonna play big one.
There's 9 of us that go tomorrow. That's the only 9 in the class.
Yeah, it's only 9 people.
I'm not good.
She just did the PSAT.
Are you prepared?
Was there any like really good speeches?
Leah and
That's all that.
I'm about to go.
Leah.
Past the cemetery because there's nobody else there.
Wait, how do you guys? Hey Connor, whose speeches were good? Leah. Who else?
Leah, Elena,
Oh, yeah, Elena's softball one was pretty good. What was it?
Seth,
That's a shower. Good. That was kind of funny.
Jonas is gonna be good. Yeah, I've heard that. Jonas told me.
Sherwood actually called me to watch it. I did. I scratched all those.
I mean, Daniela's was good only because it was terrible.
Why? What did she do, Connor?
Just the voice she did it in.
She was like throwing in weird
More
jokes.
radio?
Yeah, she recorded it.
She's smart in the first
Well,
place.
she started off like she's like, I don't have XM because I don't have XM in my car. But then, if I was a radio, I would play XM for people.
And then she's like, haha, that's not sponsorship. I'm like, what?
And then she goes, I'll have to go put the chords in there. Makes it back to the Fox chords.
Emily, are you home?
Oh, you're gonna cancel.
It's gun day.
Is she on time today?
All right, hey, here's what we're gonna go through today. We're gonna go through a couple notes here today. I have no idea what time we're gonna end this at. So, So we'll just kind of go, and if we don't get to the homework, too bad, just I don't mind. So I just want to get to notes today. I really want to talk about domain and range today. Do a bunch of examples on how we find domain, like for interval notation, and then how to find values when you evaluate a function where you plug things in. So that's kind of what I want to go to today. So if we don't get to homework, it's not a big deal. Because I always said I want to do like every other day, kind of have an assignment on this. But I know this one took a while. So, but I want to talk about kind of where we're going for that. So let's discuss the section we're in. We're in section 1.2 now, right? So 1.2, which is function. We introed this yesterday. Now, yesterday's topic, if you were gone, we talked about relations, right? Coordinates, graphs, mappings, tables, inverses. Inverse will be a huge topic later on. Later on, like when we're doing linear interpolation, coming up with equations for data. We're going to do that later. Okay, but for right now, we're dealing with functions. Our goal today, we need to talk about domain and range. These are the big topics we need to discuss. I want to make sure that you know every aspect of that. Then, I want to talk about, with domain and range, can we find a minimum and a maximum? And what those are. That's one of our goals I want to discuss today. That goes really with like domain and range kind of thing. And the last part here that I want to talk about is evaluating. Can we evaluate the function? So that's kind of our goal today. All right. Do we understand what I want to get through? Pretty basic. I mean, this stuff should seem easy. It is. The only weird part will be this domain and range part in the beginning, knowing how the interval notation works for that. I just want to make sure that we're comfortable with that, because we're going to use that in pretty much all the sections beyond this idea of like giving you domain and range. Okay. So we'll do kind of an example like we did yesterday. Okay, and that is an open circle. All right, so let's talk about domain and range first. So on this problem, it looks like it's continuous, but what's the problem?
It's missing a part right there.
One little piece. One little dot in the middle of that whole graph. So for domain, that will be an issue. For range, it won't be, and I'll explain that. Okay, so domain, it's your x values, correct?
Yep.
Okay, it's x values. So when we're looking at like x numbers this way to this way, and don't worry about the y's, but x numbers. What's the smallest x number over here? Which direction is it going? Negative infinity, right? It's going that direction. It doesn't look like it's stopping. It has an arrow. So it's going to keep going to the left. That's my smallest x value. Because when I write domain, I always go small to big. Well, my smallest value is a negative infinity. That's like it's going towards that direction. It's not a number, it's a direction. Then, as it comes up, it looks like I'm touching all the values here, here, and here. These are all good, except for what number is this on the x-axis? That's 0. That's a problem. We cannot include 0. So I need to skip over the number 0, which is kind of weird that I'm skipping over. It's one number that I have to skip over. It's a single digit. So that's where I put it here. I'm not including 0, skipping over, not including 0, and then going up this direction. Because I have to start just past 0, so I have to start with decimals. That's why I'm not putting a 1 here. I have to start just past 0 because I have decimals. And what number am I going to that way? Positive infinity. That is your domain. You see the difficulty now. That we use parentheses because we don't include numbers. We don't include the 0 because we obviously skipped over it. We use that union. And we don't use the brackets on the outside because they're infinities. Infinities are not a number. You don't include it. Just a direction. Okay, do you see how that works? Okay, now let's talk about range. In our goal today is just do a few of these so that we get really good at this. So range is the y values. So we have to start small to big. What's your smallest y value that we can use? -8. What's the biggest one we can use as we go up? Well, it looks like this would be an issue, right? It's not. Here's the reason why this is not an issue when you're doing range. It's using all these numbers, and I know there's an open circle here, but it's literally taken over by this number. So it's actually kind of like it's filled in. Because I can actually use the number -1 here on the y-axis because this has a value. So it fills the gap for that dot. If they were both open circles, there's an open circle here and here, then we'd have a problem at -1. But it looks like it's all filled in. So it's all filled in. So what's the highest y value I can have? Positive. It's basically all real numbers. Yeah, but she's left to go down to talk to Joe.
Oh, that's what she's missing. Okay, thank you.
Yeah, that was weird. She just like walked out without saying a word, and I had to chase her down the hallway, figure out where she was going.
Okay, thanks.
All right, so for the y values, it's all real numbers. There's no gaps as you go up on that one, just left to right, because this spot here really filled the gap in the vertical. Does that make sense? Like why you include every number, including the -1 on the y-axis. We're using y numbers for range. Don't look at these x numbers. Some people always get that mixed up. Okay. Any questions, comments, concerns on domain and range so far? Okay. Now here's the question: does that have a minimum? No. There's no minimum in that thing. Does it have a maximum? No. Because it doesn't start and stop anywhere. It doesn't. Okay, so that's the weird part. Okay. So now let's go on. Let's take a look at a different one, right? So I'm just going to take a look at a slightly modified problem here. So let's go with so this is my function, some type of function. Now, here's the question. Is it a function, yes or no? Talk about that. Yeah. Why? Why is it a function? Vertical line. When you draw a vertical line, anywhere on this graph, it only hits one spot. It doesn't magically hit two. It's not like the situation where it's like this. Now, if I had a situation like this, now we have an issue because when I draw the vertical line, it's literally going to hit that spot and this spot. That would be a problem. That would make it not a function. So, but right now, this is good. It doesn't matter. I know there's some gaps. It doesn't have to be continuous all the way to negative infinity and all the way to positive infinity, but we do have a function here. There's some type of formula we can come up with, like the piecewise function we could use that would represent this. Okay, so let's first start with the domain. What are my x values I can use? Let's start with that first. What's the smallest x number? -4? I think it's -4. Yeah. So -4. Now, parenthesis or bracket? Bracket. Why a bracket at -4? It's included. It's a solid dot. Right? There's no arrows. It's a solid dot. So I can use a bracket. What's the next number I'm going up to? So that's 9. Bracket or parenthesis? Bracket. Union, because there is a gap. There's a gap here. So I have to do a union. And what's the next number I start at? 10. And is that a bracket or parenthesis? Bracket. And it goes up to 12. Bracket. That's your union. No parentheses. There's no open circles. There's no arrows going to infinity. It starts and stops, so we have brackets. I didn't have that weird situation where I had like a parenthesis at 9 and a parenthesis with 9 starting because there was a gap. It ended at 9, started at 10. So there wasn't, it didn't pick up after the number 9. It was like we had to take another step before we started again. Okay, does that make sense for domain? Okay. Range numbers. Say it again. -3. So -3 in the bracket up to -1. Bracket or parenthesis? union.
Oh, no, I like 0. Sorry.
0.
I don't know what I'm thinking of.
0 up to 4. Is that a bracket or parenthesis?
Bracket.
It's included. There's no open circles like that. So there's your range. Remember, you're only using y values. Don't look at the x numbers. Look at the y's. -3 up to -1. It skipped, started at 0, and went up to about 4. Now, here's my question. Does it have a minimum? Yes. What's your minimum number? -3. You only use the range numbers to tell me minimum. So it's -3 is your bottom number. Maximum? 4. Okay. Those are the absolute min and maxes. Okay. There's an absolute min and max. So there's different types of min and maxes, which is kind of harder to wrap your head around. There's things that are called absolute min and maxes, and then there's relative min and maxes. And relative is when a problem does something like this. Let me give an example of a relative min and max. It's when you have a problem that does this. I'm going to go into open circle. Okay. Same exact idea. This will be my last example for domain range. And I want to talk about this idea of min-maxes. Okay, so domain, x numbers, right? So this number here is 1, 2, 3, 4, 5. So it starts at -5. Now, bracket or parenthesis? Bracket. And it goes up to, doesn't look like we have any problems. It's all pretty continuous until this number is 12. 12, now do I need a parenthesis or bracket? Parenthesis. There's your domain. No arrows, nothing like that. So I don't need to go to infinity. There's no breaks in the graph, so I don't need to have that union idea. So that's pretty easy. Range numbers now. Range numbers. What's the smallest range here? It's 10, yeah, -10. Parenthesis or bracket there? Bracket. Yeah, it's included. It's solid. -10 up to, what is that? 9.5? 9.5? Parenthesis or bracket? Bracket. Okay. So there's your range. And I know some people are like, well, there's an open circle. It's not open if you're looking vertically. There's no open circle if you're looking vertically. This spot took over. This was actually filled in by this number right here. If this was an open, then you'd have a gap.
Maybe juniors and seniors need to see Joe from Accelerate Athletico. You can report down to the locker room.
Then you see Joe. All right. Now let's talk about this idea of min and max. There is an absolute min. There is an absolute maximum. Right? What's your absolute minimum value we're going to hit? So absolute min is -10. Absolute max is 9.5. All right. Does that make sense? I think the idea is about highest and lowest point. Now, there is such a thing as called a relative min and max, which is a goofy little term, I know, but there is a relative min and max. And those are any time you have like hills and valleys. They don't have to be the tallest or lowest points. They could be the points in between. We would have relative mins. Like this part right here, this is a relative maximum. It did like a camel, right? So it looked like it could have been a maximum, but then later on there was an absolute that was way higher, right? This is a relative minimum. It wasn't the lowest point, but it was a valley at some point. It was continuous from left to right side. Does that make sense? You don't do it for the end caps. We don't do it for these. We don't do it for those. You only do it when it's flowing from left to right. So it's like a curve kind of a thing. So, what are these numbers? So what would this relative max be here? 3. That'd be a relative max. That'd be like a little, it did a little bump here at 3. And the lowest point here is what, -3? So those are relative min and max. They're not the tallest point and lowest point, but they are peaks and valleys that happen. All right. Questions, comments, concerns on the idea versus absolute versus just relative mins, maxes. Again, it has to be continuous flowing. Absolutes don't have to be. It's just where the graph started and stopped. Okay. So, we talked about min and maxes, we talked about domain and range. Is there any questions, comments, concerns? Did that make sense to you, the idea of brackets and parentheses idea? Okay. I know these are like the first couple days we intro it, so I want you to get used to it so we can start using that more and more in the range and stuff, especially for values like this. We'll come back to a problem like this here in a minute. Question?
What relative min and max was and stuff?
Relative min and max, they're not the absolute tallest and lowest point. They're not the absolute tallest and lowest points. It's just like when in the graph and it's kind of going up and down. Yeah. It's those other peaks and valleys that weren't the tallest points. They're just kind of other bumps or valleys in the road. So like on this graph, it was these two. It could have multiple relatives, right? Because this thing really kind of keeps going up and down, and then it ends with like this thing. You know, it had absolutes, right, tallest points, but then all these other like peaks and valleys, they're all relative, so you can have a bunch of them. Make sense? All right, that was a good question. Got to figure those out. Okay. Any other questions on that? The relatives, you can have multiple relatives. Absolute, there can only be one. Okay, let's go to this idea of like evaluating a function. In fact, I'm going to use this graph to do it. Okay, and I want to discuss how we can do it. There's two types of evaluating here. Okay, so let's say that this function is g of x. Let's say that's what this graph represents. It's some function that's named g. Right, so what this stands for, if you don't know, this is the name of the function, and this is the actual like variable that they're using in the problem. Okay, does that make sense? And then it would have some formula back here that would represent it. Okay, whatever that is. Okay, and we can eventually piece those together later on. Okay? All right. Now. All right. So here's the idea. For the actual function itself, if we're going to be evaluating, here's what they're going to actually ask you to do in the book. They're going to give you a graph like this. They're going to give you some name for the function, and then they're going to ask you a series of questions that are like this. So this is part A. They're going to go, okay, I want to know what g of number 1 is. Okay, so what that means is that you're going to look at the g function, which is this graph. You're going to find the number 1, and which variable is this one associated with? X. So you're going to find the x-axis, find the number 1, right? So that's the x-axis number 1. What is your value that this graph is giving you? What is that number right there? 2.5, negative 2.5, right? That would be your answer. It would be negative 2.5. You're evaluating the graph. You're looking where 1 is on the x-axis and what y value is it spitting out. Does that make sense? Like that's what you're doing. You're finding very specific values. So if I were to say, like maybe on problem number 4, what is g of the number 5? G of 5. Well, we'd have to find 5 on the x-axis. So the x-axis 5 is 1, 2, 3, 4, 5. So this is 5, right? And up at the top, what is that number here? That's the maximum. So that's what, 9.5? 9.5? That'd be the value that it's spitting out. Does that make sense? Like what you're doing? Or it could do a problem like this. G of some number is equal to negative 10. So now on this problem, it wants to know what x number will give you this thing. What number can I plug in here? So that's the question mark. That it'll spit out a negative 10 for an answer on the graph. So negative 10 is way over here. This is where negative 10 is at, right? So what value is that? What number do I need to plug in? So that's this number. That's the one. That's the hypothetical number. So they can go backwards. What you just did there, what this is, like finding y, finding this negative 10 on the y-axis, and figuring out what x number gives me that, that's an inverse. That's what you're doing. You're giving me that hypothetical. When will sales be the lowest on this particular sales chart? What caused it? it was that item at number 10, whatever that was. Maybe it was the month. Maybe you're looking at sales for months. This month, November, was our lowest sales month, and it picked up after that. That type of thing. Maybe this is the part where you made a bunch of sales, and then you changed the product, so now people stop buying it. That type of thing. Okay. It happens. You change the product, people don't like it, they're not going to buy it. That type of thing. And so then you got to make a modification, and hopefully it goes back. All right. Does everyone understand evaluating? Like looking at a graph and interpreting things. That's one type of evaluation. That's very nice when you can look at graphs and they actually have data associated with it. It's pretty easy. Here's the hard part. It's doing problems like this. They're going to give you 3 or 4 different functions, whatever they are. So we have a G, H, and an F function. They're different formulas, as you can see. And they're going to ask you to do something like this. So maybe this is your problem. Maybe they're going to ask you to find F of 5. So now you don't have to graph. You don't look at the graph and find 5 on the x-axis and find what value is giving me that y value. What do I have to do with this 5 now? Plug it in. You have to take, this is your F formula. This is it, right? You have to plug the 5 into it. So 5 plus 3 times 5 squared minus 1. So wherever there's an x, you're plugging 5 into it and you're solving it. It should be just a number in the end. So this is 5 plus 3 times 25 minus 1. So this is 75 plus 5. And we're going to subtract 1, which is what, 79 in the end? That would be 80 minus 1, so that's 75. Again, you're still following the order of operations, so I still had to do exponents first, multiply, then I added, then I subtracted 1. That's it. Okay, do you think that's pretty easy? Okay, pretty straightforward, right? What if they did this? You agree that's not a number, right? Not like a 5 or a 10. I still have to plug it in. So you have to go to your original G function, which that's the function over there, right? This is the G function that's on the list over there. I have to take this and plug it into the x's. So this is what I have. Now I have to simplify. So that means I'm going to have to write 2 parentheses here. That's x plus 2, x plus 2. 3, x plus 2. Then I have to solve it. I have to FOIL it out, distribute, and see what the final answer is going to be at the very end. So if I do this correctly, if I FOIL first outer and last, that'll be x squared plus 4x plus 4. Because again, first, outer, last, and then eventually the x will make these. Over here, what do I have to do with this? I have to distribute, right? So I have to distribute the -3, so it's -3x minus 6. Then I can add so it looks like the x's will combine to make 1x. 4 and the -6 will make the -2. There's my answer. It won't go any further than that. That's what I have. I'm not gonna factor the part. You don't need to do that. I just want to know what it is in the very, very end. Okay. Questions on evaluating so far? Okay. Here's what I want you to try. I want you to try one problem, and I'd like you to put it in your notes. Put it in your notes. In fact, if you get this right today, I will not give you homework today. Okay? I will not give you homework when you get this right.
Everyone gets it right?
Yes. Everyone.
Well,
Yes. So now it's a pressure. Pressure's on. Here we go.
This is a group effort, right?
Tolerate you.
Oh, this is easy. Just plug stuff in.
So
did this last year and got it.
Yeah.
Well, I don't remember Connor, so that's fine.
Okay. If you get this right, for sure, we will not have homework today. Never remotely close. You will have a day off. Yes. I will give you plenty of time to work on this. That means you cannot discuss with your neighbors, though.
We discuss precedent. Technically, they're not our neighbors.
Everyone's your neighbor.
I was so confused. Like, how am I supposed to solve that if it's just G, F, and H and X plus 1? I didn't know. I thought you were just leaving that written stuff to discuss.
No.
Alright,
Yeah, I was about halfway through and I realized that, so I had to go back and erase most of it.
Alright. It might need to give me a little extra time here.
Alright. Good, we figure out those little issues first.
No, I said
so much stuff in that.
I said right there. So I'm gonna look at it.
That does not make me confident about this framework.
Hey,
You're telling me.
I think you just wanted to give us homework today.
I'd rather have the homework.
I don't think you do. There's some big numbers. Moving around. Some numbers are being 1,000. I've already finished it.
No. Okay, we're fast. If you have, let's say you have an x squared in parentheses, and then you're squaring that, would that be x to the fourth?
Yes.
Okay. Okay. So I think I'm on the right track.
There, what you got?
Yo, you're giving up too easily.
I'm giving up the.
You guys are giving up too easily.
I'll take the homework.
Yeah.
I don't think you want us.
I don't want to see it. Let's just do it tomorrow anyway. Definitely do this tomorrow.
I don't have 5 turns on yet. What the heck?
That way.
Hey, keep going. Keep going.
2004 x squared, or x to the fourth, minus 1,920 x to the third plus 352 x squared.
Ooh.
I messed up on which one.
The x squared.
I have negative.
What are the rest of your things?
2,304
Yeah.
x minus 1,920
Yeah, keep going. Let's get past the expert term.
20 x.
Just your expert.
I have negative 128 x squared.
Say it again.
Negative 128 x squared. I don't know how I got that, but
I got like 48x to the fourth plus 96x to the third minus 68x squared minus 26x plus 7x times itself minus 3x.
I think I'm gonna
What
call
was
him.
the right x?
I'm gonna throw him the.
37.
Oh,
You're 48 off.
That's good enough.
Alright.
So no homework?
yeah, no homework for the effort.
Ooh.
Okay, hey, explain to me, what do we do first?
Plug in the x plus 1
For h. You're gonna do that first, like an onion, right? So when you're plugging the x plus 1 into h, this is what you should have. Right? That's how you plug it into h. You're plugging the x plus 1 in here. So when you distribute, this is what you have. 4x plus 4 minus 5. So that means that's 4x minus 1. Does that make sense?
Yep.
This is the item that you're plugging into f.
Yep.
Because that, we've replaced this thing now. Yeah.
That's what I did.
And so now you're working
Forgot
way
the
out.
onion method.
Yeah.
Okay, so now, what's f? What's f?
X plus 3x squared. Oh, so you'd have to plug in the first minus 1 and call that, yep.
Okay, and then you got to simplify that. And whatever you get for this, whatever this parenthesis is, you're plugging into g. And g is the complicated one. Because g, whatever this thing is, whatever that thing is, which is big, because you're squaring this thing first, then taking it times 3, and then adding, the 4x minus 1 and subtracting the 1, whatever this thing is, whatever this monstrosity is, you're plugging into g, which is this. Whatever that number is, you're going to square it,